Okay, so we're going to be talking about finding finding the solution to what we call a mixture problem. And this is where we're mixing two different solutions and we're trying to come up with one specific type of mixture. So here we've got a solution with, or a scientist with two solutions. One is 70% salt, the other one is 95% salt. And when she puts these two things together, she wants to get a grand total of 80 ounces with a saturation of 90% salt. So one of the things that I like to talk about here is we're going to use two different equations. And the first one is going to be pretty straightforward because when we're looking at this, we've got two different, it's like I've got two different beakers. I don't know what their volume is, but in beaker A, I've got some level of stuff, and 70% of that is salt. So this is going to be some sort of concentration. Well, actually, this is beaker A. This is literally 70%. So this is going to be 0.70 times however much is in that beaker. That's how much salt is contained in that one. And that's apparently don't have a very good pen there, so I'm going to switch over to this other one. For B, okay, this one also, I don't know what size this is, whatever's in there, but this one is 95% salt. So this is an even higher concentration of salt. So whatever is in here, whatever volume is in here, 95% times that volume is going to be equal to that salt. So this gives us a good setup. What we're going to do now, though, is we're going to take, I want to take a look at just the grand total of A and B. I know that grand total for our volume, we need 80 ounces. So I'm going to say my volume of A plus B is going to be equal to 80 ounces. So this is both the salt and that inert ingredient. It could be water, it could be some other medium. We don't know what that is at this point. But then I can take a look at just my pure substance, or just the salt. And with different things, this could be ethanol, it could be some sort of drug. There's all sorts of things we could do in this. But we know how much is in, I know how much is in each of these. For our solution A, it's 70%. So it's 0.70 times that amount, times that volume. For our amount B, it's 95%. So 0.95 times that amount B. Now, what we need is 80 ounces, but we want a 90% concentration. So if I put these two things together, I should end up with a 90% solution. So I'm going to have my 90%, so 0.90 times that 80 ounces. This right here is my system of equations. So the nice thing with this kind of setup is this is actually a really, really good setup for substitution. If I were to solve this top equation, my volume equation, for either A or B, and I'm going to solve this for A. If I were to solve this for A, so if I were to say A plus B equals 80, I'm going to subtract B from both sides. I'm going to end up with A is equal to 80 minus B. So now I've got an expression that I can substitute in right here. Things that are equal are interchangeable. So now I'm going to take a look at this equation. I've got my 0.70, but instead of A, I'm substituting in this expression, that 80 minus B. And then from here, we're just gonna continue this as we normally would. This is our 0.95 times b, and I'll keep this here. I don't want to change anything just yet, just because it's 80. Wow, I'm running myself off the page. I'm sorry about that. But now we can go ahead and, but this, as messy as this is an equation that we should be able to solve. And good news is, I believe you're going to be able to use calculators in this section. So when I do this, I will end up with, let's see here, 70% of 80 is going to end up being, this is going to end up being 56, and then minus our 0.70b, and then plus our 0.95b. And over here we've got 90% of 80 is going to be, I'm going to say that's going to end up being 72. I'm going to add together my like terms. I've got two b's over here. So I'll have this 56 plus 95 minus 70 is going to end up being, what's that going to be? That'll end up being 0.15b. My brain is still a little bit fuzzy this morning for whatever reason. Well, actually, I suspect it was my cat trying to wake me up at night. Oh, actually, that's 0.25. That makes... And that's equal to our 72. So now I'm going to go ahead and subtract 56 from both sides. So I've got my 0.25b is equal to, that's going to be a 6, 1. Actually, that's going to be a 6. So that's going to be 16. And from here, I can divide both sides by this 0.25. And I've got b is equal to 64. And now I can back substitute into one of our original equations. And honestly, back substituting into this bottom one, it would work, but it's going to be a lot easier to use this, or even a version of that first equation. So I already knew that a was equal to 80 minus b. Well, this is going to be 80 minus that 64. So I've got a should be equal to, that looks to me like 16. So I'm going to have 16 ounces of solution A, and 64 ounces of solution B. And I think you could probably hear I had a small fluffy helper. Okay. So for our second particular example here, we've got a bartender. It's after quarantine, and he is definitely trying to liven up the party. Or who knows, maybe he's just trying to put everyone to sleep. Brand A drink contains 35% ethanol. Brand B, 60% ethanol. And he's making a punch of bowl, or he's making a punch bowl. He wants a mix that contains 50% or 45% ethanol. And I actually forgot part of my example. To get actually 50 ounces. That's a pretty, that's a decent sized punch bowl. 50 ounces. So here, we're going to take a look first at our volume. And we know what our total volume should be that we want to get. We want to get 50 ounces. So when I mix brand A and brand B, and sometimes these might be, we could even, say, okay, we're mixing absinthe and bourbon or whatever. I'd say use variables that are meaningful to you. X and Y are great for sort of generic variables, but sometimes it's more helpful to have a specific type of, name what they are. Anyway, it's useful to have meaningful variables, but I've got brand A and brand B. 50 ounces. Okay, well, we know that's our grand total. That's what we want. That's how big our punch bowl is. That's how much we want to put in there. Then we want kind of the strength of our drink. This is the strength of the ethanol. So here, I know that brand A is 35%. So if I want to figure out how much ethanol is in that, well, I take that volume A and I'd multiply it by that 35%, 0.35. For brand B, okay, it's 60%, so 0.60, and times brand B. And this is going to be, our grand total should be 45%, so we want this to be 0.45 times that 50. And these are our two equations. And once again, this is a great setup for us because this is going to be able to, these two things are going to, or this is a great setup for substitution. So once again, I'm going to solve this for, I could solve it for either A or B. It doesn't matter which one. I think before I solved for A, this time I'm going to solve for B. So I've got A plus B equals 50. This time I'm going to, I'll subtract A from both sides instead of, so I've got B is equal to 50 minus A. And we're going to use this expression and we're going to substitute into this second equation for B. So I've got this 0.35A plus our 0.60, and now I'm going to multiply that by, I'm substituting that variable B with this expression, that 50 minus A. And that's equal to our 0.45 times 50. Now I can go ahead and solve this. It looks complicated because we've got our decimals in here. These look like some slightly bigger numbers. Don't worry about big numbers. They're always going to break down faster than you will. So 0.35A plus 60% of 50, that's going to be 30, I believe, and then minus our 0.60A is equal to, let's see, 45% of 50, that's going to end up being, still we're going to have a decimal here, that's going to be 22.5. Now this is going to look a little bit weird for a minute, and I have some people they're a little bit weirded out when they realize that we've got some negative numbers that happen in here. Don't worry, wait till the end because the negative numbers are going to cancel out. So 0.35a minus 0.60a, we're putting together our like terms. This is going to be minus, I want to say that's going to be, yeah, minus 0.25a plus this 30 is equal to our 22.5. And now I'm going to subtract 30 from both sides. Minus 30. So negative 0.25a is equal to, that's going to be, oh, what'll that end up being? 7.5. So when I, oops, sorry, negative 7.5. Knew I was missing something there. Now when I divide both sides by our negative 0.25, negative 0.25, it looks like I've got a is equal to 30. So that tells me that I've got 30 of one thing, and once again, and this happens with all of our systems of equations, once you find one answer, you're going to back substitute into your other equation, one of your other equations. And we have our solutions. So I've got 30 ounces of brand A. I've got 20 ounces of brand B. And now folks have found a brand new way to be sick after quarantine. Alrighty, I think that's enough for that example.